Fowler's definition of the repository pattern gave us a lot to chew on. In this lesson, I want to focus on the phrase that he used, this query construction. He uses it in this context. He says, in such systems, it can be worthwhile to build another layer of abstraction over the mapping layer where the query construction code is concentrated. This becomes more important when there are a large number of domain classes or heavy querying. In these cases particularly, adding this layer helps to minimize duplicate query logic. So how does one go about encapsulating query construction in the repository? Well, as the old saying goes, the devil's in the details. So, for example, Fowler explicitly states that the repository pattern involves a query object, or rather a criteria object. So on page 323 of his book, he says the following. Client objects construct query specifications declaratively and submit them to the repository for satisfaction. Then later he says, repository replaces specialized finder methods on data mapper classes with a specification-based approach to object selection. So at this point, perhaps it would help to see an example of what I think Fowler is saying. So imagine, if you will, a simple class, a car class. And the car class has an ID, a make, a model, a year, and so on. Just simple properties like that. And given that, there is a repository interface called iCar repository that looks something like this. And you can see that it defines about 5 different methods. Some of these start with the word find, so there's find all, find by ID. And then there's also methods to add, remove, and so on, cars from the repository, or actually the storage underneath. So it would be the insert and delete methods. Okay. And so this is a good example of what a repository might look like, at least in a simple case. Now, I'm not going to create the car class. I just told you basically what it is. I'm not going to create an implementation of iCar repository of type car because they're not all that interesting and would actually cloud the subject at this point. Instead, what I want to do is pretend that we already have those classes defined somewhere. And then I want to look at examples of code that might call methods and properties of the concrete implementations of those classes. So let me just say it this way. This is what you might see in a domain model class. If they were trying to get out all the Toyotas inside of the database and create instances of the car class that can be worked with. All right, so here we go. var Toyotas equal repository dot. So the repository variable would be an instance of iCar repository of car. Okay, so repository dot find by, and then you pass in this expression. Given E, give me all cars, essentially, that have the make property equal to Toyota, and then order by year. All right, so that's one. Here's another example using the iCar repository of car methods that were defined. Here, var first car equals repository dot find by ID, passing in the number 1. All right, and then just an example of how to use the add functionality. Var new car equals new car. You can explicitly put in some of the properties that you want to set as an initializer, and then you would call repository.add, passing in a new instance of car, so the new car variable. All right, and I actually stole this example from a popular MSDN article, and I changed some things around it about it to make it easier to read. I'm going to reintroduce that article later on in this series. But back to what Fowler actually described. He said repository replaces specialized finder methods on the data mapper classes with a specification-based approach to object selection. Now remember, the data mapper we said was essentially going to be something like ADO.NET or Entity Framework. Okay, so in the code example, there's 2 different approaches at work here in this iCar repository. The first, a finder method, namely find all and find by ID. You might be able to imagine a dozen different finder methods for all the ways that the domain layer needs to retrieve cars from the data store. Perhaps you have a find by make, a find by model, a find by year, and so on. All right, so that's one approach to creating your finder methods. The second is a specification-based approach, and you see that in the find by method. Find by, and then passing in a predicate called expression of func of car bool. All right. This second one allows you to pass in a predicate using the link to entities method syntax. So it allows you to do this, like you see on screen. var Toyota is equal repository.findBy, given E, return all makes that are equal to Toyota. Okay, so clearly the second approach is what Fowler is talking about when he says that the repository replaces specialized finder methods on data mapper classes with a specification-based approach to object selection. So the find by method is now extremely powerful. It can do just about anything. It's possible to add code in here that's nonsensical and could perhaps bring a database to its knees. I also think that the find by method that you see on screen right now could be very hard to unit test. How can you test all of the possible predicates to ensure that it operates correctly? Now, the biggest concern that I have about the find by method, the specification-based approach, is that while it's great for ad hoc queries, do you really need ad hoc queries? I get the feeling that the domain layer is no longer driving the development of the persistence layer. And I'll have a little bit more to say about this when we talk about how to think about repositories in the context of domain-driven design in a whole other video. But the domain layer seems to only need a method called, in this case, find by make, but we've given it carte blanche to look for anything that it can conceive of by putting this expression func of car bool. All right. Now, having said that, Eric Evans seems to have no problem with this. Now, Eric Evans, being the father, I guess you could say, of domain-driven design, and on page number 153 of his domain-driven design book, it's the one with the librarian here. All right. He basically says this, that one particularly apt approach to generalizing repositories through a framework is to use specification-based queries. A specification allows a client to describe, that is, to specify what it wants without concern for how it will be obtained. In the process, an object that can actually carry out the selection is created. He says the specification-based query is elegant and flexible. Depending on the infrastructure available, it may be a modest framework or it may be prohibitively difficult. Now, in defense of what apprehension I expressed just a moment ago on whether to use finder methods or a specification-based approach, Evans does say on page 152, says the easiest repository to build has hard-coded queries with specific parameters. These queries can be various, retrieving an entity by its identity, provided by almost all repositories, requesting a collection of objects with a particular attribute value or a complex combination of parameters, selecting objects based on value ranges, such as date ranges, and even perform some calculations that fall within the general responsibility of a repository, especially drawing on operations supported by the underlying database. Later on page 153, he says, hard-coded queries can be built on top of any infrastructure without a lot of investment because they do just what some client would have had to do anyway. And in the end, he says, even a repository designed with flexible queries should allow for the addition of specialized hard-coded queries. They might be convenience methods that encapsulate an often used query, I guess what Fowler would call a query encapsulation. So this might be convenience methods that encapsulate an often used query or a query that doesn't return the objects themselves, such as a mathematical summary of the selected objects. Frameworks that don't allow for such contingencies tend to distort the domain design or get bypassed by developers. All right, so I see his point here, and I agree that being rigid about this will only lead some developers chucking the whole idea completely and preferring to do without a repository at all instead of just preferring the strangling simplicity of mixing the concerns of business rules and data access in the same methods. However, there's still something that just doesn't sit well with me about the find by approach. Before we go any further, let's give these two approaches real names, and then I can discuss what my reservations are. So personally, I use the term simple repository to describe the finder method approach to querying the repository. I saw this term coined somewhere, I can't remember where, and so I can't give it proper attribution. However, I'll define the simple repository like so. Prefer finding objects using specialized finder methods. But then there's also this specification repository, which I'm going to define like so. Prefer finding objects using a predicate or specification. Now keep in mind that those are my terms for the most part, or at least my definitions. I'm adding them to keep it clear what I'm talking about here. Okay. Of course, you could create a single class that took both approaches. We're merely talking about implementing more methods here. But I guess in my mind, there's a bit more to it than that. It has to do with the fundamental way that you approach development. In the simple repository, I'm creating specialized finder methods because that's what the domain layer needs, right? The simple repository allows the domain layer to drive the development of the system. If the domain layer client needs a repository to grab a specific set of domain objects from the data store, I'll create only that method, nothing more. In the specification repository, I'm allowing for a predicate, an object that encapsulates the search criteria, to be passed in because it's convenient for the developers. It's convenient to define the predicate in the call to the repository class. And if the client code changes or expands, the developers won't have to implement additional specialized finder methods to accommodate those changes. Hopefully by now you're thinking, yeah, but YAGNI, YAGNI, you ain't gonna need it. I'm going to have more to say about these approaches when we talk about unit testing in a whole other series. But in a nutshell, these are the two that you'll see most often. Well, actually, that's not exactly true. There's a third, and I'm going to devote a whole lesson to abstract, or rather generic repositories. We'll come back to that a little bit later. All right, so in the next lesson, I want to focus on the specification repository. Specifically, I want to pick apart the code that you'll see often that looks like what we saw just a moment ago. Something like I enumerable of t, find by, passing in a predicate of type expression of func of t bool. All right. What in the world does that mean? I want to better understand what that does and how you can implement a specification query if you really want to. If you want to go with Fowler and Evans and go ahead and follow their advice instead of creating specific finder methods, the simple repository method like I would prefer to create. All right, we'll talk about specification repositories in the next lesson. See you there. Thank you.